The objective of this lesson is to guide you through writing code to initialize and collect temperature and humidity data from the Adafruit AHT10 sensor. By the end of this lesson, you will have a fully functioning sketch that reads data from the sensor and displays it on the Arduino IDE serial monitor. In the previous lesson, you learned how to install and manage libraries using the library manager of the Arduino IDE. Now, we are ready to use one of these libraries to interact with the physical sensor, in this case, the AHT10. This lesson will cover the basic code required to initialize the sensor, capture real-time temperature and humidity data, and display it on the Arduino serial monitor. This will provide the foundation for future lessons, where we will display the data on a TFT screen and send it over the network. So, let's write the code that allows the ESP32 to connect to the AHT10 sensor and collect data. To work with the sensor, we need to include the necessary libraries that initialize the sensor and manage the collected data. The library we will need to install for this lesson is the Adafruit AHTXO library. The reason why we will go with this one instead of the AHT10 is because the AHTXO receives constant updates. So in order to install the required libraries, we go to the library manager and search for the Adafruit AHTXO. We install it with all the needed dependencies. Once the library has been installed, we are ready to begin programming. We will of course begin by including the library. Next, we create an object for the AHTXO class, which allows us to connect to the sensor. Do not forget the semicolon and also to comment your code. After we have created the object, we will go to the setup function. In the setup function, we will initialize the sensor and configure it to start sending data. We will also, of course, set up the serial monitor for debugging and viewing the sensor data. So let's start by initializing this serial monitor. Serial.begin, we went over this before. And with, of course, a baud rate of 115/200, same as the last time because we are using the ESP32. Now we are going to initialize the AHT sensor. So the function that initializes the sensor is called simply aht.begin. This starts the sensor, but this is not how we're going to use it. We're going to use it in an if function. We're going to do that by writing if and then in parentheses exclamation mark. This means that if not initialize sensor, then it will do something else. The sensor should start automatically once connected to the board, but we're going to check if it did not initialize automatically if it was not recognized by the faulty wires. So if exclamation mark aht.begin, then we will put a curly bracket and print failed to find AHT chip. This lets us know that the sensor could not be found, and thus the AHT sensor was not initialized. Then we're going to create a simple running function that would stop the program if the sensor was not started by implementing a small delay. Now we have initialized our serial monitor as well as our sensor, so let's start collecting data from it. First of all, also in the setup, we need a confirmation that the AHT sensor was initialized correctly. And now that we checked if the sensor did not begin, we would stop the program. But if the sensor began, we will ignore the previous code and just print that the sensor has been found. Great! Do not forget the semicolon. Now that we know that the sensor has been initialized, we will collect the data. To do that, we will use preset functions by the AHT library. We will create new variables that will store these values. This is the temperature one. And of course, the humidity one. Great! Now that we have all of our data saved, it's time to print the sensor details. We print the sensor details to know the parameters of our data. These functions are also used for debugging. Let's go over the setup function. We start the serial monitor at 115/200 baud rate so we can print our messages on the serial monitor. Then the aht.begin function initializes the aht10 sensor. If the sensor is not detected, the code will print an error message and halt the execution. Next, we retrieve the pointers to the temperature and humidity sensor using getTemperatureSensor and getHumiditySensor. These pointers allow us to access the sensor data. Now that the sensor is initialized, we need to collect the data from it and display it on the serial monitor. Now that the sensor is initialized, we need to read the data from it and display the information on the serial monitor. The sensor data will be captured within the loop function, which will repeatedly execute and query the sensor for fresh data. We will start by creating event objects to hold the sensor readings. We will do that by using the census event_t. Now that we created the objects to hold the readings and we're looking for the events, it's time to actually store the data. And also do not forget to comment it. Amazing, now that we have the data saved within our sketch, it is time to upload it to the serial monitor. This will be done by primarily using the print function. Remember to include the space in the string, as the serial monitor does not include space automatically. In the Rust serial print, we need to include the degrees Celsius. A neat little trick that you can do is hold down the Alt key and press 0176. When you do that, a degree symbol will appear. And these are all the functions needed to print out the temperature data. We will need to do the same for the humidity measurements. The temperature event is not a string, so it must not be contained within quotation marks. Great, now the code is complete. But before we start testing, I'm going to add another delay so that the code does not run continuously. The delay function works in milliseconds, so 1000 will be equal to 1 second. Now let's go over the loop function before we move forward. We create the sensors event to temporarily store the sensor data. After that, we call the getEvent method on the temperature and humidity sensor objects to populate these objects with the latest sensor readings. The data is then printed to the serial monitor. We output both temperature and humidity with approximate labels and units. A 1 second delay ensures that the program doesn't flood the serial monitor with data too quickly, allowing us to observe the results at a readable pace. Now that the code is complete, it is time for troubleshooting and testing. Before uploading the code, ensure that the ESP32 is properly connected via USB. Also, you should ensure that the AHT10 sensor is properly wired to the ESP32 board. This is my current wiring setup. You can see that the VCC is connected to 3 volts using a red wire, the ground is connected using a black wire, and the data SDA and SCL are with a orange and yellow cable. Once all of the connections have been checked, you may click the upload button to compile the code. Once the code is successfully uploaded, open the serial monitor by clicking the magnifying glass at the top right corner of the screen. You can alternatively press Ctrl-Shift-M, and that will give you the same result. Remember to check for the correct baud rate. If everything is set up correctly, you should be seeing real-time temperature and humidity readings printed out on the serial monitor. If not, what you can do is click on the side button of the ESP32 to reset it. Let's see if the sensor has been initialized. We can see that all of the data is printed on the same line. This can be fixed by adding the ln argument to the serial print. This will start a new line. Let's try again. And it appears that our sensor is working perfectly. It's printing out all of the necessary data, and if we reset it, the code will of course output the sensor details. So congratulations! In this lesson you have written a successful sketch that initializes the AHT10 sensor, collects data from it, and displays it in real time on the serial monitor of the Arduino IDE. By leveraging the Adafruit AHTXO library, you were able to focus on the high-level functionality of the sensor, without worrying about the low-level communication. This is why libraries are so important when working on IoT projects. This code forms the core of your IoT project. It continuously captures real-time environmental data. In future lessons, we will extend this code to implement a TFT display and also serve the data via a web server.